Okay, it's been a while since I've looked at the Liberator board, mainly because I was waiting for my boards from PCB Way. Well, they came in the mail last week, and I had 4 different designs built. This first board is the one I need primarily for the sync problem I'm having to get the reset circuit verified and working. That's going to go there. These guys, these larger ones, are going to go to replace these 4 missing ROMs that are here. It's going to take 2 of them. So they're going to go there and there. And then I've had a number of these made. If I have any of these 4116 RAMs bad, I'll be replacing them with this board and a 4164 RAM. The other board that I had built does not relate to Liberator. This is for Gremlin Hang On. It'll be a board to replace the ROMs, the 2708 ROMs on that board with a single 2764. And it will go in the place of the Z80 CPU. So this is a future project, but today we're talking about Liberator, so it'll be these 3 different boards and 4 boards total that I'll be populating. Actually, I don't know if I even need this. I just had them made in case I need to replace some of these 4116s. I can almost guarantee at least one's bad. They always go bad. So anyway, let me start building these up, and I'll be back. Okay, so I'm using a breadboard here to stabilize these devices before I solder them. You'll see I've installed headers for each of these, and I put them in the breadboard to keep things from moving around on me so that I don't have to hold it with my hand and solder at the same time. And so that's just a trick. I've seen that done before, so it's not anything new, but just thought I'd share that before I continue. I got all the boards populated and I've got them installed. I need to program a couple of 2764s here, and I need to program a WinBond to 27C5, 27C512 for this guy. This is going to be the sync prom. You'll notice a couple jumpers on that. If you take a closer look at the board, it supports both 256 by 4 and 512 by 4. I'm going to be using the 256 by 4 configuration, so that means I need to add jumpers for A and B, which is on the left there. You'll see there's spots for A and B. So that's what I did. I installed 2 jumpers in the A positions on both of them. So that's going to make this act as a 82S129, which is a 256 by 4. So got everything built up. Now I just got to program the devices, the EEPROMs and the double EEPROM. Okay, I got all the chips programmed. 2 2764s to replace the 4 2532 Planet ROMs. And I've got the 1 W27C512-45 EEPROM, or double EEPROM, to replace the 82S129 256 by 4 prom. So we should get further because of this. This should solve the reset problem and start running the RAM test. I do expect at least one of these to be bad. I mean, the odds of them all being good are very slim. I don't know what the history of this board is, but when I received it, it was missing parts, and that generally means the RAMs are bad. But we'll see. We'll find out what happens. If the voltage ever gets switched or applied incorrectly, then that will knock out these RAMs, and it could be all of them. Alright, so I'm about to start testing this and see what happens. Alright, so I'm powering it on with all my new stuff in here. It's not working, and it's constantly resetting. Here's the reset. It's constantly resetting. But if I look at the data pins coming off the processor, so that's D7, D6, D5, D4. Okay, so the first 3 look good. D4 looks weird. D3, D2, D1, and D1 looks weird. And D0. So D1 and D4 look like there's a problem with it. When I pull the EEPROM out of this processor board, they all look the same. They all look like they're correct. So something's going on either with my board design or with the data on that ROM. I'm going to double check it and see if it's good. So that's where I'm at. Okay, so I did some probing around. I took this board and I removed the buffer, onboard buffer here, and all of these lines here look good coming off the EEPROM, so I've eliminated the EEPROM in the processor as the source of the problem. So I started probing on the board, and this chip here seems to be the source of the problem, so I'm going to replace it. And that E2 chip is right here in the schematics. It is the transceiver chip for the data going to and from the processor. Bits, let's see, bits D1 and D4 were having problems, both of them on this. Now, there could be a short or something, so I'm going to look around for a short, but if I don't find anything, then I'll replace that. All right, so I did replace this chip, and things improved. One of the bits was fixed, so maybe that chip was bad. The other was not fixed, so let me show you that. Let's see. That's D7 right there, so D7 looks okay. And notice I took the ROM board out, and I just put the processor in just to evaluate why this bit D1 is screwing up. So that's D7 right there, D6, D5, D4, D3, D2, D1. Well, where is it? So there's the one, that's the data line that I'm having a problem with. It's bad even with that board out. So there's something on this board causing it. It's got to be a short somewhere. Haven't found it, and that's preventing the program from running far enough to get to start self-test. Once I resolve that data bit problem, then I'll be able to continue. But it's getting late today, so I'm going to go ahead and stop. You can see the screen is getting a sync. We've got a well-defined box here, so the sync signal, this guy here, looks to be working correctly. I don't know anything about these yet. I don't know if this is working or not because we haven't gotten that far. So I've removed the POCUS as part of this test because I want to make sure those were not causing the data bit problem. Okay, that's it for tonight. I'll continue next time.